Alright, so metal and non-metal. Metal, as we already know, is in group 1, 2, 3. So it will become positive 1, positive 2, positive 3 ions by releasing electrons. Non-metals are group 5, group 6, and group 7. They will receive electrons become negative 3, negative 2, and negative 1. And basically, they will look like this. Positive, negative with the full outer shell, like that. 7 electrons from its own, 1 is from someone else. Okay, so we have talked about ionic. Ionic forms a giant lattice. It goes on and on and on and on. They have strong electrostatic force of attraction. They have high melting point, high boiling point, and they conduct electricity only when molten, but not molten or aqueous, but not in solid form. Okay. All right. So that's the first thing we learned when I met you. After that, we talked about covalent. Covalent is sharing electrons between non-metals only. So the ones that we have learned so far is simple covalent. All right. So for example, hydrogen has 1 electron, another hydrogen has 1 electron. They share 1 pair of electrons. So remember, we drew all this before. We drew ammonia, we drew, okay, we drew ammonia, we drew carbon dioxide, we drew all these covalent bonds. So covalent bonds is basically sharing a pair of electrons. Okay, Ken, do you remember all this? Do you remember all this? Okay, now what happens is when they share electrons, okay, what we have learned is when they share electrons, that's it. This is one whole thing is one molecule. And another molecule shares a pair of electrons. But between the molecules, is there any strong forces of attraction? No. No, remember it is weak. Weak intermolecular forces of attraction. Okay? Okay. All right. So, because between the molecules is weak intermolecular forces of attraction, the melting point and boiling point is very, very low. Remember, there's nothing to hold them together. So they boil, they melt very, very easily. They separate very, very easily. Okay? All right. Now, because of this, they also have do not conduct electricity. Okay? They do not conduct electricity in any form. Okay, so today we're going to learn covalent, but this covalent is called giant covalent. Okay, now the concept is the same. Giant covalent structure also has covalent bond. That means, for example, carbon. The electron arrangement of carbon is 2,4. Okay, can? So carbon forms 4 bonds, right? In a previously, we learned about methane. Methane is like this. CH4. Do you remember this? This is methane. We only draw the outer shell. So this methane will look like this. CH4, like this. Do you remember? This is called a displayed formula. This is called a dot and cross. Okay. If this is a methane molecule, between this methane molecule and another methane molecule, is it strong or weak intermolecular? Weak. It is also weak intermolecular. So what happens is in giant covalent, something different happens. Okay? Something different happens in giant covalent. Each carbon has 4 bonds. All right? Then each carbon bonds with another 4 carbons. All right? Now, one carbon must have how many bonds? 4. This carbon already has how many bonds? 1. How many more does it need? 3. So it forms 3 more bonds. Okay? Who do you think you should bond with? Another 4 carbons. It bonds with another 4 carbons. Now, these carbons, how many bonds do they have each? 1. How many more do they need? 3. So do they continue to bond? Yeah, they continue to bond with 3 other carbons. Now, when does it stop? It doesn't stop. It goes on and on and on and on for millions and millions and millions and millions of carbons. When there is about 3 trillion carbon atoms all joined together, it forms one tiny molecule called a diamond. So is it a tiny molecule? No, it's a giant molecular structure. So if each carbon forms 4 bonds with other carbons, this is called diamond. Okay? Each carbon atom, 4 bonds with 4 other carbon atoms. Okay? So let me show you how it looks like in real life. There. This is so it goes, I'm not going to draw so much. It goes on and on and on like this. Okay? And millions of this make one diamond. So, is the covalent bond very, very strong? Yes. Does it have many strong covalent bonds? Yes. So therefore, this is called a giant covalent structure. So this makes diamond very hard. High melting point or or low melting point? High. Very high melting point. And do you think does it conduct electricity? No. So it does not conduct electricity. Okay? Cannot? Can you understand? Okay, so this is why diamonds are the hardest substance in the world. Okay, please write this down. Scroll up. Okay? So because high diamond is like that, it's the hardest substance in the world. What do they use it to make? Diamond rings, of course, jewelry, of course, and also they use it to make the drill, the bit of the drill bit to drill other stuff. Okay, ready? Can you understand? Okay, now this is what happens if diamond is compressed over millions and millions of years under high pressure and high temperature. So where do you think you will find diamond mines? In the cave, because the cave used to be soil and the soil was compressed to become stone caves. La, literally like Minecraft. Yes. So it's in caves like that over millions. So this is how they drill for it. It's in not it's actually not cave, but people dig a hole in the mountain. It becomes a cave like that. Get it? Okay, now di carbon is so versatile that it can do something else also. It can bond with three other carbons actually. Okay? So this is known as graphite. Do you know what is graphite? Graphite is your pencil lead. Your pencil lead is not made from lead. Then why do they call it pencil lead? Because people are stupid lah, I also don't know why. Okay, pencil lead is not lead. Pencil lead is actually made from graphite, made from carbon, the charcoal, the same thing that you make, okay, the same thing that you make during uh uh barbecue, and the same thing you need for pencil. Okay, so this one, it is every carbon, it bonds to three other carbons. Okay, it bonds to three other carbons. Like that. Okay, three other carbons. And it goes on and on and on. But now, this one just now was 3D. This one you think is how many D? 3D or 2D? It's like, actually, it's like a piece of paper like that. The carbons are arranged. This one, you can make it flat like that, 2D. So it goes on and on and on like that. One big flat plane like that goes on and on in one ring. Can you see the ring? One ring got how many carbons? 1, 2, 3, 4, 5, 6 like that. One ring. And then next to it, another ring. 1, 2, 3, 4, 5, 6, another ring. And then next to it, it will be another ring. It will go on and on like that. Okay, what shape is this? Here, another ring. Hexagon. Okay, so graphite are arranged in this one. Graphite is each carbon, three bonds. Three bonds are each carbon, three bonds, and it forms hexagonal layers. It forms a layer. So this one, you repeat it about 5 million times, it forms one layer. Okay, when you write on a piece of paper using a pencil, one layer comes out. So this is one layer, and then you have another layer like that. So you have millions and millions of layers. So this is one layer. This is second layer like that. Can you imagine? It just goes on by layer, layer, layer like that. So in hexagonal layers. Hexagonal because it's 6 carbons in a row. Okay? Okay. Can? Do you understand? Hannah? So the layers, are they easy to come off? Yeah. So what happens is the layers can slide over each other. And so it is used as a lubricant. Do you know what's a lubricant? Let's say I open and close the gate, it goes What do? I put oil. Correct or not? That's called a lubricant. WD-40, yeah. Something like that. So it's black color because why? Why is black all black color? Because there is graphite inside there, blended inside there. It's very, very slippery. Can you understand? So it's a lubricant. It can be used as pencils to write. Okay, Ken? Now, does it still have high melting point and high boiling point? Yes, of course. It's still a giant covalent. It's still giant. So it still has high melting point, high boiling point. But there's one thing special. The special thing is because only three bonds are made, that it can conduct electricity. So graphite is the only non-metal that can conduct electricity. Okay, do you all understand now? Can? All right, I'm going to draw for you one more. It is called silicon 4 oxide. You need to tell me whether it resembles diamond or it resembles graphite. Okay, so this is called silicon 4 oxide. It's also a giant covalent structure, SiO2, okay, otherwise known as SAD. Okay, can you please write down the electron arrangement for silicon and oxygen now? Go and find in your periodic table. Okay, silicon is 284. Oh, 14, yeah, 284 lah. Oxygen is 26. So each silicon has four bonds, each oxygen has two bonds. So who do you think it will look like? So this is what happens. This silicon has four bonds. It bonds to four oxygen. Oxygen has two bonds. It bonds to two silicon. Now this silicon has four bonds. It bonds to four oxygen like this. Okay. Does it look more like diamond or does it look more like graphite? Diamond. So it also has a tetrahedral shape. It's also giant covalent. It's similar to diamond. Same as diamond. So it is also hard, also high melting point, and also does not conduct electricity. So in the giant covalent, the only one that conducts is graphite. So graphite is special. All the other giant covalent do not conduct. Okay? Okay, ready? Can? So do you understand giant covalent? Yeah. Understand giant covalent? Easy, ah? Okay, now we go to the last one, which is called metallic. Okay, please remember, I've recorded all the lessons. I've sent all the videos online in your group chat. Okay, I also have given you all your notes. The only thing I haven't done is sit down and feed you. So please be okay, proactive for your own education. All right. Now, metallic is like this. Okay, let's say I have a piece of metal. Okay, I have a piece of metal, solid metal. Okay, let's say this is iron, a piece of iron. Now, when you were learning baby science last time in year from one, from two, or year seven, you will learn about atoms and you learn about particles. And if I ask you to draw, you will draw like this. Iron, 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 iron. These are all, what is it? Atom, 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 atom. Right now, they're all iron atoms. Okay, now, that is technically true. But what happens is, metals like to do what? Metals like to gain or lose electrons. Look at this. It becomes positive because electrons are negative. So when it becomes positive, 1 positive, 2 positive, 3, has it gained or lost electrons? Lost. Group 1 loses 1 electron, group 2 loses 2 electrons, group 3 loses 3 electrons. Okay? So it loses electrons. So metals are like that. Metals always become positive. So in reality, inside here, it's not really an atom. Let's say it's sodium, for example. Let's say it's a piece of iron or sodium. It's a metal, yeah. Sodium is 281. In order to achieve full outer shell, how many electrons does it release? Oh. 1. In order to achieve full outer shell, it releases 1. So when it releases 1, it becomes Na positive. 28. Okay? Correct? Now, what happens is every single sodium will tell each other, we're very bored. I'm very bored. Can I go out walking a bit? That 1 electron, can I go out? And everyone will say, okay. So that 1 electron will say, okay, let me go out walking a bit. Ta-da, like that. Okay. So now every single sodium is sodium or sodium positive. Positive. But you must understand, it did not form a compound. It's not a compound. It's just walking around. It's still, it doesn't react with anybody. The electrons are just flowing around. Okay? So this is how metals actually look like. Okay? There is positive metals in a regular arrangement. Okay? Positive metals in a regular arrangement. And then the electrons are freely moving. Alright? Does it have high melting point or high boiling point or low? High. Why? Because it's positive and negative. Electrons are negative. So there is strong electrostatic forces of attraction between the positive ions and the negative electrons. They will all stick together. Okay? Now, all metals are shiny. All metals are malleable. Do you know what is malleable? Malleable means when I knock it, okay. Glass, when I knock it, it shatters. Metal, when I knock it, it dents. That's called malleable. The reason is because all these layers of atoms or ions can slide over each other when you knock into them. Okay? Because the layers of ions can slide. So this is why it is malleable. Okay? Do you think it can conduct electricity? Can metals conduct electricity? Yeah, of course. That's why they're using for electrical wires. They can conduct electricity because the electrons are free. The electrons are free. Electrons are the ones that carry electricity. Okay? All right. Today, what I'm going to do is I'm going to give you a summary of this entire chapter. Next week, I want to start a new chapter already because we're dragging and dragging and dragging. Okay, and I'm going to give you homework. All right. And if you not today, next week, it's like a mini quiz. Okay, you go back and do it. Okay, I will only mark whoever gives me back. If you don't give me back, I will just assume you're not interested in learning. Because no point. I chase after you. You didn't do homework. If you didn't do homework, you're just sitting down there copying answer. I can just send you the answers. I don't need to waste at other people who actually did the work. Okay? So next week, I'm going to give you a quiz to take home and do. I don't want to sit down here and look at you do. Take home and do the entire quiz at home. You can refer to your books first if you want. Okay? Because that's, if you haven't studied, that's how you study. Okay? And please pass it back to me. I'll only mark those who pass back to me. All right. Okay. So the next thing we're going to do is I'm going to do a overall for all four. We're going to compare. It's going to take a bit of time, and I want you to take your exercise book and you have to you need big space. So you do it um landscape. Okay, so that you have the whole paper to do this. It's quite a big table. Okay, don't draw first. Don't draw first. Let me show you what I want from you. Okay, don't draw first, Let me show you what I want for you. Okay, what is required. Okay, so this is what we're going to do. You don't draw first because I do, then you can see the layout. So we're going to talk about type of bond, definition, melting point, high or low, and then Y. And then conducts electricity, and then Y. Okay, so it's quite a lot of writing that you need to do. Okay, so the first type of bond we're going to talk about is I'll give you an example like ionic. So example is sodium chloride. Okay, do you remember how ionic is? It's positive, negative, negative, positive, and does it go on and on and on? Okay, so it is the attractive forces between what? Not electron. Ionic is positive and negative ions. Correct not? Okay, so what kind of attraction is it? Electrostatic. So remember, it is like positive ion and negative ion, not electrons. Okay, so it is electrostatic forces. FOA is forces of attraction. Forces of attraction between what? Positive and negative is called oppositely charged ions. Okay? So high or low melting point? High. Because the electrostatic forces of attractions are very, very strong. Okay? Does it conduct electricity? Okay, here's the keyword. In what state? In solid? No. But in molten and aqueous? Yes. Do you remember what is aqueous? Aqueous means dissolved in water. Molten is liquid. Okay? Why no? Because ions not free moving. In a solid, in a molten, yes, ions are free. Remember, it's ions. Get it? Okay. This is the first one. You have four to do. Okay. You have covalent. The first one is simple molecular. And then you have giant. And then you have metallic. Okay. Do you understand what I need from you? Sorry, what? Okay. Okay, do it now. Hurry up, quick, 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 quick. So you will need the whole piece of paper. All right. So actually, the definition for covalent is the same. A covalent bond, there's only one definition. It's, yeah, as long as it's a covalent, the definition of covalent bond is sharing a pair of electrons between two atoms. A pair of electrons. Okay? So an example of simple molecular is like hydrogen. Yeah. Sorry, sorry. No, for IG no need. IG very, very relaxing one, very easy one. No need to talk so much. Huh? Okay. So it is low, like so small. Okay. Low melting point. I cannot write. Let me try this. No, no, no. I'll make it. I'll write bigger. Okay. So it's low melting point and boiling point. VP is boiling point and MP is boiling point. Why? Because there is weak intermolecular forces of attraction between molecules. Okay, so it's weak intermolecular. Sorry? Correction tape. Okay, I don't have. Sorry. Okay, can see? Okay. Does it conduct electricity? Does not conduct electricity in any state. That means solid, liquid, gas, or cannot. Because no free ions or free electrons. It only has neutral molecules, okay? Okay, ready? All right. Giant covalent. We go example of diamond. It's the easiest. So it has strong covalent bonds. Oh, sorry. Definition is still the same. Okay, definition is still the same. It's still sharing a pair of electrons between two atoms. But now it just goes on and on and on. There's many, many covalent bonds. Okay, so high or low melting point? Very high. So you must be able to explain why. Yeah, very high. So it has strong, there's no forces of attraction, strong covalent bonds between all atoms. Okay, it has strong covalent bonds between all atoms. And the reason why it does not conduct electricity is the same. Okay, because it does not have any free ions or electrons. Okay, ready? Yeah. Okay, the last one, metallic. Okay, I'm going to move this down because there's no place here. So metallic is like iron, magnesium, sodium. Okay, so this one, the definition is very specific. Okay, the definition is very specific. It is lattice or regular arrangement. Have you heard of the word regular arrangement? Okay, regular arrangement of positive metal ions in a sea of delocalized. Delocalized means free electrons. Okay, and then there is electrostatic forces of attraction between positive ions and negative electrons. Don't say positive and negative ions. Positive and negative ions is ionic. Okay, ready? Okay, the last one. Okay, high melting point, boiling point. High. Why is it high? Because there is, so it's high melting point and boiling point because it has strong electrostatic force of attraction between positive and negative ions. So it's a similar answer. It's in the definition. The answer is in the definition. Okay? All right. Ready?
Yes.
Does it conduct electricity?
Yes.
Why? Free moving?
Yeah.
What? Free moving what? Electrons! Ions is ionic! Electrons. It's not ions. Okay, so yes, and this is the most important, in solid, in any state, That means it's the only one that can do in solid or liquid. It doesn't hit gas lah. Okay, it's the only one because that has free electrons. Not ions, are electrons. So you can go home, use mahjong paper, draw, and stick on your wall. Okay? Okay, now, next week, what am I going to do? Start the next chapter, and then what am I going to do? Give you a, and I'll only mark those who give me back. If everyone gives me back, then I'll discuss in class. Okay? Yes lah. Okay. Oh, sorry, Jai not done yet. Done. Okay. Yeah, I will print it, yeah. I'll print it and give it to you. Okay, now, we're going to do something now that you need to memorize even though you don't like it. Okay? So, remember previously, let's say if I gave you magnesium and chlorine, how do you write down the electron arrangement? Magnesium is 282, chlorine is 287, and then magnesium becomes magnesium 28 Mg2 plus, and then chlorine becomes 288, chloride 1 negative. What is the formula of magnesium chloride? MgCl, MgCl what? How many magnesium, how many chlorine? Huh? MgCl or what? No. How many magnesium? One magnesium. How many chlorines? Two. Because magnesium releases two electrons, each chlorine receives one. So I would need two magnesium to one chlorine, right? So the ratio is one magnesium to two chlorines. The ratio is 1 to 2. So how do I write it in the formula MgCl2? Do you remember? Remember not? That's why MgCl2. Okay. So if I had magnesium and oxygen, magnesium would become Mg2 plus. Oxygen becomes O how many negative? Wow. Oxygen is 2,6. Faster. 2 negative. So what is the formula? MgO. Because the ratio would be 1 to 1. Do you remember? Okay. So now we're going to learn all the other ions in the world. Yay! You need to remember. All right, because some you can get from periodic table. How do you know oxygen is 2 negative? Because it's in group 6. Remember not this one. This doesn't change. This thing should be drilled into your brain like the what you call it? The diamond drill. Okay, this one you cannot forget. Group 1 becomes a positive 1 ion. Group 2, positive 2. Group 3, positive 3. Group 7, negative 1. Group 6, negative 2. Group 5, negative 3. That one cannot change. Get it? Can? Okay. So, anything that becomes a positive ion, this one, for those of you who are going to take Form 4, same thing you have to memorize anyway. Okay, all these have to memorize anyway. Okay? Alright, so positive ions are called cations. Negative is called anions. So we start with the big one, it's easy. Potassium, sodium. Okay, for example, group 2, magnesium, calcium. Group 3, of course, aluminium. Okay, who others are metals in the periodic table? The one in the middle is called what? Transition metal, right or not? So that's when there's special ones. Sometimes it is Fe2 plus. So it's called iron 2 ion. Then there is Fe3 plus, iron 3 ion. Who can tell me what is Ag? Silver. Silver, there's only positive one. Okay. Zinc, there's only 2 positive. Lead, there is Pb2 plus, lead 4, lead 2 and lead 4. Okay. Copper, there is copper 2 and copper 1. Alright? Okay, and then there is another special one called non-metal. Non-metal positive ions. There is hydrogen ion. And there is NH4 positive one is ammonium ion. Okay? Group 7. Okay, this one the name changes up. Chloride, bromide, fluoride, iodide. Group 6, oxide. Please write this down. Oh, you need to memorize this. Sulfide. Okay? Group 5 will be 3 negative. Phosphide, nitride. Anions got complicated ones. So, S2 negative is sulfide. SO4 2 negative is sulfate. SO3 2 negative is sulfite. Okay? Yeah, so much fun, right? Okay.
Oh, fuck. Who made this?
Not me. N3 negative is nitride. So, N O3 negative is nitrate. NO2 negative is nitrite. OH negative hydroxide. CO3 2 negative is carbonate. Okay, two more only. Too small.
It's fine.
Two more only, yeah.
It's fine.
HCO3 1 negative is bicarbonate or hydrogen carbonate. And finally, there's one more I can't remember. Or phosphate. Okay, please write this down.
Uh, it was
Huh? This is fun part, yeah. Please write this down. You need to remember this. So here is cation, here is or anion. You want me to send this? I'll send this to you.
big over.
Go. I will send this to you, then I will freeze the thing so that you can. I'll send this to you, okay?
Whoever made this was called a party. It's not invited to party. Well. Yeah. Yeah.
Okay, I'll freeze screen first, then you all copy the rest later. How do I freeze? There's a number that you freeze screen. Then I freeze the screen already.
Yeah. Maybe